our first lab and that lab is point-to-point single area OSPF version 2 configuration. So as we already discussed about the theoretical concept of OSPF, now in this lab we have to configure the router ID, and then we have to configure the OSPF network command and enable the OSPF routing on our routers. Then we have configure the passive interface, and at the last we have to perform the basic verification of OSPF. So if you see this topology, we have three routers: router 1 that is connected with router 2 and that is connected with router 3, and this is the standard topology which we already discussed in our theory lecture. So every router 1, for example, they have two wide area network connections. Router 1 is connected with R2 and router 1 is connected with R3 also on a serial interfaces, and router 1 have a one local area network, one network is there. Okay, so similarly router 2 have two wide area networks. One is connected with R1, one is connected with R3. Both network addresses are given here, 10.110/30, and I think all of you know about the /30 means. It's a subnet mask. It represents subnet mask. It's like 255.255.255, 252. Router 2 also we have a local area network 2, which we have 192.168.20.0 network. So similarly for router 3. So this is our basic topology. This is the addressing table given here. All the interfaces which we are using in our configuration and the IP addresses are there with their subnet mask prefix notations are there. Already IP addresses are configured on all the router interfaces. Okay, so in this topology, we configure the OSPF by using the network statement command and wildcard mask, and also we using the network statement with quad 0, and additionally also we use configure the router ID and their passive interfaces. So the first part in this, if you see here, they ask us to configure the router IDs, and I repeat one more time that router ID is the unique ID for routers in OSPF process. Okay, so start with the router 1. We have to configure first the process, OSPF routing process on all three routers, and you know that process we can choose any number between 1 to 65,535. If you have any doubt, any confusion, go back and see listen that video lecture for the module 1 of OSPF, in which I already clearly define what is the purpose of process number. So start with the router 1. I double click router 1, then this is the user mode, enable config T, and then we have to enable the OSPF process. So the command is router OSPF and process ID number. So in my case I am using number 10. So this is the first command you have to enable the OSPF process. Now you notice that this mode is changed and you are entered into the configuration mode. Similarly, the same command you have to run on both other routers, because we have to enable the OSPF on all routers. So on router 2, again we have enable config T, router OSPF and the process number 10. With the router 3 we have router 3, make it bigger one so you can easily enable with the privilege mode, then go with the config T with global configuration mode and type router OSPF process 10. So this is how we enable the OSPF process. Now if you notice that they ask us to configure the B part router ID and set the OSPF IDs on all these three routers. So they mention the router IDs, like for router 1 the router ID is 111, for router 2 the router ID is 222, for router 3 the router ID is 333. So starting with the for example router 3, so for the router 3 the router ID is 3.3.3.3. so what is the command? The command is router dash ID, and after that you write that particular ID 3.3.3.3. so this command will configure the router ID on the router 3. Similarly, go with the router 2, router dash ID and 2.2.2.2, and similarly I configure router ID on a router 1, that is router dash ID 1.1.1.1. So we complete our two tasks. We configure the process ID, then we configure the router IDs by using the command. Now come to the part 2. The part 2, in that part 2 we enables the networks for the OSPF routing. So in this way, how many statements are required to configure OSPF routes to all the networks attached to the router 1? So remember the one point. First, on a router 1, first check how many the directly connected interfaces they have. So in my case, they have 1 interface, 2 interface, 3 interface. It means this router have 3 different networks. So if you have a 3 interfaces, then you use the network commands 3 times. If you have a router with 2 interfaces, then you use the network commands 2 times. So in our case, we have 3 interfaces, so we use the network command 3 times. So the command is very easy, which we use it. So if I open this one, you can also check this one. Okay, so this is the router ID we configured. Now so for the router 1, we have a 3 networks we have to advertise. Okay, now how we calculate uh, dotted decimal notation. So for the router 1, we have here /24 subnet mask. /24 subnet mask, whenever you have, it's mean 255.255.255.255. Now if you want to calculate the wildcard mask, so definitely as we already discussed in the theory part, you have to minus 255.255.255.255 from the subnet mask, and you will get the wildcard mask. So in my case, the wildcard mask should be 255 minus 255, it should be 0, 255 minus 2550, 255 minus 2550, and 0 minus 255, it's 255. So this is the wildcard mask. So the now the wildcard mask for this network for /30 subnet mask is 250.000.255. For the /30, this is the subnet mask, 255.255.255.252. And again, if you want to calculate the wildcard mask with the same method, you will get the answer 0.0.0.3. So this is the method how we calculate the wildcard mask. Now the command is very easy and you can easily configure. The command is, I will start from the network, router 1. So the command is network followed by the network address. So first I take the LAN network address of router 1, that is 192.168.10.0. Then I write the wildcard mask 0.0.0.255. Then area, because we are configuring this router OSPF version 2 for single area, so area should be 0. So this is one network we configured, the command also mentioned here. Okay, area 0. Now two wide area network also we have to configure network, then 10.1.1.0, 0.0.0.3, and area should be again 0 because it's a single area OSPF configuration. Then again one more command network, and then we have 10.1.1.4 and 0.0.0.3, and area should be 0. I think. Okay, so the space problem. So the 3 networks I have configured. Now similarly method we have to follow for the router 2, router 3, and router 4. But if you exit from here and go to the privilege mode and want to check the show IP route command to check the routing table, nothing will be show uh, uh, except the directly connected networks. So there are 3 directly connected networks, 1, 2, and this one is our third 3 networks. And for all these networks we have configured network command in OSPF. So this router basically advertise their network to other remote routers that I know these 3 networks. What about you? So similarly we go for the router 2, and we also configure the OSPF network addresses and network command with the wildcard mask. So the network, again for this R2 we have one LAN network, that is 192.168.20.1 wildcard mask. Okay, now what we do, we configure this router with the concept of quad 0. So quad 0 is a concept that instead of you writing a network address, we are using the interface IP addresses. For example, if you want to check the IP address of this router's interfaces, so do show IP in brief. So here you see the IP addresses of interface for gigabit is 20.1, 10.112 and 10.119. Now the OSPF routing configuration by using the interface IP address with the help of a quad 0. Quad 0 means in place of a wildcard mask we put a wildcard mask like 00000. So I will show you. First you type the network command 192.168.1.1. Network address is 20.1, that is the interface IP address as you see here. Then instead of I calculate this is a class C, then I calculate the wildcard mask, I directly put quad 0, all octets are 0, and same area 0. Similarly network, what is the wide area network? 10.1.1.2, that is the interface address, second interface address, have you noticed here? Okay, then again put quad 0 and area 0. Then again we have a third network, that is 10.1.1.9, again quad 0 and area 0. You see that message because it make a neighbor relationship with the router 1 full. If you remember that there are different states of OSPF. So this is the third command we have from here. So now all the three networks addresses are advertised, but in on R2 we configured with the concept of interface IP address instead of we configure the network address. So this is the second thing we have to remember, that the other method of OSPF configuration using the network interface IP address quad 0. So this is the step 2, we finish it. Now for the router 3, they're asking me like on router 3 configuration required with the OSPF, which interface R3 should be configured with OSPF. So the simple answer is that go to the router 3, how many interfaces? 3 interfaces. So all 3 interfaces we have to run OSPF on a router. So now, so these are the 3 interfaces, G00, S01, S0111, all these are the interfaces. Now this is the third method. In this third method, if you notice that we configure the OSPF routing on the router interface. What does it mean? Instead of we configure here, first I exit here, then I check which interfaces I have. So you remember the command do show IP int brief. So now if you notice that how many interfaces I have, active interfaces, I have G00, I have serial 01/0, and I have serial 111. Okay, so for that one, if I get bigger one, okay, so now it's clear. So on interfaces basis, I have to configure the OSPF. This is the third method to configure the OSPF on your router. So int, I enter into the G0/0/0 interface. So the mode is now config-if. So it is showed it's the interface mode. And after that, I write after that I write also you can see the command IP OSPF process number, okay, and the area. So we are using process number 10 and area 0. So because we are enable the OSPF on interfaces basis, so no need to write the network command here because we already enter into the interface, and interface have a one network only. Okay, so now go to the second interface which is serial 01/0, serial 0/1/0, and again IP OSPF process number 10 area 0, again interface as 0/1/1, and then IP OSPF, and then process number, then area 0. So basically we enable OSPF on all three interfaces of router 3. So here also you see that message loading full adjacencies like that. So this is the OSPF configuration all router. Now how we verify it? There are some commands also I mentioned in my theory lecture. Show first command, show IP route. You have to check the routing table. So if you notice that there are some new things in your routing table. Number one, O. So if you see in O means OSPF. Okay, it represents the which routing protocol? OSPF routing protocol. Which network they learn? 10.110/30. That is the remote network. And in the bracket there are two more important things. This is called the administrative distance, the trustworthiness of a routing protocol. Every routing protocol have a different administrative distance, and this is called the metric. So OSPF metric is cost. Again, I just go and watch my video lecture for module 1 OSPF, in which I explain you how to how OSPF calculate this cost. Via means how they learn this network through routing protocol OSPF via this interface IP, and that is which interface? Serial 0/1/0 interfaces. So actually we have to check how many O's should be there. So the easiest way is these three networks are directly connected for router 3. Okay, so what are the remaining networks? So one network here, one network here, and one network here. So total 3 O should be in router 3. So one O, second O, and the third O. So it's mean router 3 is fully converged and they run the OSPF completely. Again, one more command, show IP protocol. If you run this command, show IP protocol, it will give you OSPF process number, the router ID which we configured on the router 3. This is router 3 router ID. Then it's also defined which networks, 3 networks we are using, what are their distances. Okay, so this is about uh, this command, show IP protocol. Again we have one more command, show IP OSPF interface. So this is a detailed command, but also I mentioned in my theory lecture, in which you can see this interface as working in area 0. This is the router ID. The network type is broadcast because it is connected to the Ethernet. The cost is to 1, and the priority by default is 1. Okay, for that network it's a DR. So like that. Uh, uh, if you remember, OSPF maintain 3 tables. First table is a neighbor table, show IP OSPF neighbor, in which they contain the neighbor information, neighbor table information. So if you notice that the neighbor ID of other 2 routers should be given here. Their priority by default is 0. States are full. Either it is not DR or BDR, it is not mentioned here. Okay, so this is the first table, that is called the neighbor table or database table also they called. Then we have neighbor table they are called. Then we have to check the topology table or a database table. So show IP OSPF database. Okay, so and this is about the entire map. In this database you can see all the mapping, database description information, what all the information this router have. They have link IDs for all 3 routers, then their aging time, sequence number, checksum is used for error detection, link counts available. So this is the command. Router ID is given here, process ID is given here, area, which area is multi-area. So area 0, it means single area OSPF is configured. And the third command is the routing table. So show IP OSPF route, it's also a command. They will show only the OSPF route. Okay, so IP OSPF question mark, remember it is used to get what are the commands. You can see after that OSPF keyword. So question marks normally in Cisco IS it is used for help purpose. So this is the detailed information about the show IP OSPF. So hope it's the same command you can run on the other routers. Now I can show you the communication. How we check the communication? We can ping from router 3 to the PC of LAN 2. So first we have to check what are the IP addresses are there. So PC2 IP address is 192.168.2010. So ping 192.168.20.10. So it's a first packet, it's working. So see this explanation, packet is send and receive and it's working. So that is the confirmation, also the one other confirmation to check the connectivity between system to system or router router. You can also ping from here to this PC, from this PC to this PC, it should be work. Now we come to the our part. Then we have last part remaining, that is called the passive interface concept. So I hope all of you remember about the passive interface concept. Basically OSPF will send its protocol traffic out all the interfaces that are participating in the OSPF process. On the links that are not connected to the other networks such as the Ethernet or LAN networks, their unnecessary traffic consumes the resources of router. The passive interface command will prevent the OSPF process from sending unnecessary routing protocol traffic out from the LAN. For example, if you see on a router 2, all two routers, this interface is connected with other routers, so they don't need to configure the passive interface. But the routing updates which is coming from this Ethernet gigabit Ethernet interface, it is unnecessary because here they are connected the systems, and system they don't need the routing information. So what we do, for this router we can make G00 interface as a passive interface. Similarly for router 1 we make this interface as a passive. For the router 3 we make this interface as a passive. You got my point? So that is the concept of the passive interface. So how will it will work? So I will show you on here on for router 1. For router 1, if you configure enable config T, first you enter into the OSPF process, router OSPF process number 10, which we already created earlier. Then passive dash interface, this is the command. Which interface you want to make passive? G0/0/0, the ID. Similar, just press enter, this interface make passive. Now I can exit from here, show IP command to verify and the passive interface, so that is show IP protocol. So once you run this command on a router 1, so if you notice that here they mention the passive interface is gigabit Ethernet 0/0/0. Another way, if you go with show run command, so it will show all the running configuration, and you notice that under the OSPF process it will show passive interface G00/0. So this interface will not receive any routing updates of OSPF to their local area network. And remember that one point, never ever configure passive interface on that interface that is connected with another router. For example, if I configure the passive interface here on this serial interface, so it will break their neighbor relationship and OSPF update will not forward it to this router. So that is the problem. You must always enable the passive interface only the interfaces which is connected to the local area network like Ethernet, gigabit Ethernet, whatever. Okay, so this is